Okay, now we're going to look at one of the most important things in math and statistics, which is the measure of center of a set of data. We're going to look at the mean, which is one kind of measure, and then we're going to look at the median, which is another, and then we're going to ask ourselves, which one is better to use? Okay, so first let's look at the mean. A definition here. The mean is the average of the data set. So you've probably heard the word average before, and you probably know how to calculate it. Mean is the exact same thing. It's just a different word for it. So when you take the average, when you calculate the average, you're going to sum up the data points, add them all up, and then you're going to divide by the number of data points, and that will give you the mean, same thing as the average. So let's look at an example here. So here we have some data about minutes some students spent reading last night. And we list all the data here in a set. Sometimes you'll see the data listed this way. So each one of these, 66 minutes, they're put in order in this case. 66 minutes again, another student. A third student did 67 minutes, then another 67, all the way to a student who did 71 minutes, who read for 71 minutes. That's kind of hard to see from just the data points listed here. So usually making a graph is a really great thing to do. You can see the data are spread out here. Just like we saw up here, there's two students who read 66 minutes. Well, there's two dots on this dot plot of 66 minutes as well. So you can see that this data, this dot plot represents these data right here. So then you can ask yourself, well, what's the mean of the data? Now, the mean is supposed to capture, just like the median, it's a measure of center. So hopefully you would think that the mean would be somewhere around in here. Let's go ahead and make that calculation. To do that, you would add up each of these on your calculator or in a spreadsheet, or you could do it by hand if you wanted. You'd take 66 plus 66 plus 67 plus 67, etc. Another faster way would be to say, well, there's 2 times 66 plus 3 times 67 plus, let's see, 5 times 68. You get the idea. Whatever way you want to calculate it, we won't do the calculation right here, but I'll just say that the sum of these data points, when you add them all up, is 1,301. Now, you want to divide that sum by the number of data points. So that's a lot easier to calculate. You just count the number of dots here. It's 2 plus 3 is 5 plus 5 is 10 plus 4 more here is 14 plus 3 is 17 plus 2 is 19 data points. So the number of data points is 19, and then we just do our calculation up here. The sum divided by the number. So we'll take this sum divided by the number. So 1,301 divided by 19, and you get 68.5. And that is indeed right around here in the middle, between 68 and 69 is where we would have expected the middle of the data to be. So that's using the mean to calculate the middle of the data. Now let's look at the median. It's just a different way to do it. They're both great. Let's see here. The definition of the median is the middle value of the data. Or if there's two middle values, it's the mean or the average of those middle values. Okay, so what do we mean by that? Let's look at an example. Here, there's another set, a different class, of students who spent time reading last night and the number of minutes. So they varied from, let's see, clear down here at 56 minutes all the way up to 66 minutes. And you can see, unlike this data set where it's really easy to see what the middle is right around here, this one's a little tougher. You don't really see an exact middle visually. So a mean or a median would be a great thing to help you to understand where is the middle of this data set. Let's use the median here. What we're going to do is we're going to put all of these data in order, kind of like we had written over here in this case, and then we're going to find what the lower half and the upper half are and what the middle value is. And I'm going to go ahead and write this out for you here. So I've kind of color-coded. Let's see, there were a number of different data points here, and you see if you divide it in half, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 data points. So there's 8 in the kind of upper half and 8 in the lower half, and then a middle value right here of 60. So that's the middle of the data set, and so you can say the median is 60 for this data set. Now, let's look at another example with a box plot. So a box plot is really cool because it doesn't tell you the individual data points, but it tells you some really important information. And most importantly, it tells you, or one of the most important things it tells you is right here. When you have a box plot, the lowest dot here is the lowest value of the data, and the highest dot here is the highest or maximum value of the data. And then it puts a box around the middle portion of the data, and we'll explain more in later videos about that. And then it puts this dot right here, which is the median. So with the box plot, you can just read the median right off of the graph right there, so you know that the median is 73 because that's what's shown on the box plot. Now, which one is better, mean or median? Well, both mean and median are good, and professional mathematicians and statisticians use them both. Okay, so you have to just know what they mean, and you have to pay attention to some gotchas. And let me point out one gotcha here, which is outliers. Let's look at an example. Sky usually makes dinner quickly for his family, but once last week made a gourmet meal that took hours to prepare. The following set shows Sky's cooking times for the last 2 weeks. So we're going to get the number of minutes that Sky spent cooking, and just like in this last data set over here, we're going to put them in order, and we're going to color the lower half and the upper half of the data. Okay, so one day it took him only 18 minutes, another day only 19 minutes, another day only 19 minutes, etc., etc. You can see here. But then there was that one day that he spent 241 minutes. Let's see, that's 4 hours and 1 minute making a gourmet meal. Okay, so now let's understand what the mean of this data set would be. So again, to calculate the mean, we would add up all those data points and divide by the number of data points. We're going to go ahead and skip doing the arithmetic right here on the video, but you can see that if you added all these up with your calculator or by hand or on a spreadsheet, you get 509. And there are 14 data points here. You take 509 divided by 14, you get the mean is 36.4. Okay, we'll come back to that in just a second. Now let's calculate the median. The median is a little bit different than this example over here because we have an even number of data points. We have 14 data points. So if you take half of them, that's 7, and then the other half is also 7. So there's not one middle data point, there's 2 middle data points, 20 and 21. So like we said in the definition over here, you have to find the mean or the average of those 2 middle data points. And you can see that the middle of 20 and 21, you could calculate the average. You could add them up to be 41 and divide by 2 and you get 20.5. Or you could just say, oh, 20.5 is exactly in the middle of 20 and 21. So that's our median. And so it's 20.5. Now the question is, which is a better representation of how much time it usually takes Sky to cook a meal? Well, you can see that the median seems to be right about the middle of the data here, but the mean is being thrown off by this outlier, 241, because it's saying the middle of the data is 36.4, and in some ways that's true, but you can see it almost has never taken Sky 36.4 minutes or anywhere near there to cook dinner. It's either usually a much lower number or that one time it was a higher number. And so that's why the outlier is throwing off the mean. So that's just one example of how you want to pay attention to mean and median and when you're using them to see if they really represent the center of the data.